Pre-Calc 12, Chapter 5.1, we're going to be looking at graphing exponential functions. Exponential functions look a lot like powers, but there is a major difference. The variable is in the exponent rather than the base. And the base must have a positive constant. So we have y is equal to a to the power of x. And the domain for exponential functions is all reals. So let's look at some examples. We have y is equal to x squared. Y is equal to 2 to the power of x. So let's look at the table here. If we have x squared, negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on. And we get down to 12, we get 144. But now let's look at 2 to the power of negative 1. That's a half. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. We can see that 2 to the power of x is now growing faster than x squared. And as we continue, it just keeps on growing faster. 2 to the power of 12 is 4,096. Let's look at another example. X to the power of 4 and 4 to the power of x. So 0 to the power of 4 is 0. 1 to the power of 4 is 1. 2 to the power of 4 is 16. 3 to the power of 4 is 81. And so on. You can use graphs, but using tables lets you see the numbers more precisely. Now, 4 to the power of 0 is 1. 4 to the power of 1 is 4. 4 to the power of 2 is 16. 4 to the power of 3 is 64. 4 to the power of 4 is 256. 4 to the power of 5 is 1024, and we can see that it's growing faster now. And when we get to 4 to the power of 13, we get an extremely large number. This is 67 million, while 13 to the power of 4 is only 28,561. Okay, let's look at having a base that is less than 1. So, x to the power of half versus a half to the power of x. And you should recall that x to the power of half is just a square root function. Square root 0 is 0. Square root 1 is 1. Square root 2 is 1.414. And so on. And when we get to 13, we have square root 13 is 3.6. The function is still growing. Let's look at a half to the power of x. Half to the power of 0 is 1. Half to the power of 1 is a half. Half to the power of 2 is a quarter. Half to the power of 3 is 1/8. And so on. This is radically different. This is a decreasing function while square root is an increasing function. And it keeps decreasing, and the value gets smaller and smaller. And I should add some notes here. This grows much faster. And this one grows much faster. Here we have increasing, and here we have decreasing. Let's look at one last example. 2 to the power of negative x and a half to the power of x. These are both exponential functions. So 2 to the power of negative 0 is 1. 2 to the power of negative 1 is a half. 2 to the power of negative 2 is a quarter. 2 to the power of negative 3 is 1/8. A half to the power of 0 is 1. A half to the power of 1 is a half. A half to the power of 2 is a quarter. A half to the power of 3 is 1/8. So these are the same. And if we look at this, we have basically 2 to the power of negative 1 to the power of x, which equals 2 to the power of negative x. So if you're comfortable with this explanation so far, you can stop and do your homework. If you still need more explanations, let's continue. So here are the spoilers. Simple exponential functions are always increasing or decreasing. And by simple, I mean no transformations. And this is not true for polynomials. Simple exponential functions have a horizontal asymptote. Again, not true for polynomials. And if we look back at this problem, we can see that these numbers are decreasing and they're always getting closer to 0. But they never actually reach 0. And that's the same as this one up here. It's going in the opposite direction. One end will go to the horizontal asymptote, the other end will go to infinity. If the base is less than 1, then we have a decreasing function. If the base is greater than 1, we have an increasing function. And this is reversed if y equals a to the negative x. And if you recall your transformations, this is a mirror or reflection on the y-axis. And regardless of the base, again, the horizontal asymptote is y equals 0. And the range is always y is greater than 0 for simple exponential functions. However, that will change when there's transformations. And that completes this lesson.